All right, hopefully you are watching these videos only because you felt stuck, not because you're just jumping in to try to watch them for the first time. So consider the area bounded by f of x equals 2x plus 3 between x equals 0 and x equals 3 above the x-axis. So I'm going to color that area in yellow for us. So between x equals 0 and x equals 3, underneath this line, 2x plus 3, and the x-axis. So this is my ideal area that I'm trying to find. And you might be saying, Ms. Schwartz, please, we can totally find that with the trapezoid. And I agree, and we will to verify our answers. But our goal is to make sense of all this rectangle learning that we've been doing. So estimate the area using one right-handed rectangle in the interval. So I'm supposed to look from 0 to 3. I'm supposed to use one giant width of 3, and I'm supposed to use my right hand, which says f of 3. Well, f of 3 happened to be 9, so 3 times 9 is 27. That is way too big of an overestimate. All right, so let's see what happens with the left hand. Well, I'm still supposed to use just one big rectangle over the whole domain. So this time I'm going to say 3 times my left hand output, f of 0. Well, f of 0 is equal to 3. So that's going to be 9. That is way too small of an estimate. Okay, so estimate using 3 rectangles. Trying to get these blue lines to go away. There we go. Estimate the area using 3 right-handed rectangles of equal width. So if I wanted 3 rectangles, I'm going to take 3 minus 0 divided by 3. Each one is going to have a width of 1. So I've got this little baby graph over here, so I can work on it a little bit. 0 to 3, each one has a width of 1. And I'm supposed to be using my right hand. So for this first rectangle in green, I have a width of 1 and a height of f of 1. Plus, this second rectangle in red, using my right hand, I have a width of 1 and this time a height of f of 2. Plus, finally, my blue rectangle, again, has a width of 1. This time, a height of f of 3. Calculating that all out, we get an area of 21. Still an overestimate because I'm using right-hand rectangles on an increasing function. So let's go through and do the same thing, except this time we're going to use our left hand. So in this first partition, I have a width of 1. But this time, I'm going to use my f of 0. Plus, still have a width of 1. This time, I'm going to use my left hand, which is f of 1. Finally, a width of 1. This time, using my left hand, is going to be f of 2. For a total of 15. Now, in thinking about that, you should notice that this green rectangle is the same as this red rectangle. And this red rectangle is the same as this blue rectangle. And it's only our left endpoint that we add on here, while it's our right endpoint we add on here. All right, find the exact area using a limit summation. So I'm going to help you get started. The limit as n goes to infinity, I equals 1 to n, f of a is 0 plus b minus a over n I times b minus a over n. Okay, well, what was my function? My function the whole time was 2x plus 3. And my width is 3 over, that's an n. That's ugly. Okay, so again, 2x plus 3 is where I'm getting that from. All right, so cleaning this up, I get 6 over ni plus 3 times 3 over n. And multiplying in that 3 over n, I'm going to get 18 over n times I plus, 18n squared, hopefully you caught that, over plus 9 over n. So now we get to use our formulas. Remember, there's a lot of different ways you can show your work for this, but now that I'm going to plug in my formulas, I can drop the sigma. That's an n. This would be n plus 1 over 2. Plus, this becomes 9 over n times n. You can take some time to show that step for yourself. So now this limit, all this is even. I get 18 over 2, which is 9, plus 9 for a grand area of 18. Here's the cool part. Find the exact area using geometry. So let's think about this. I can break up this area into this blue triangle and this green rectangle. Well, what's the area of the triangle? It's 1/2 base times height plus the area of the rectangle, which is base times height. There's the green 9, and I do actually mean the green 9. There's the blue 9, and I do actually mean the blue 9 from my limit. And I end up with a total area of 18. Now, I hope you recognize that using geometry is a lot easier than the limit summation, and we want you to do it. If you're given the ability to use geometry because you have a straight line or maybe you have a perfect circle in your coordinate plane, please use geometry. Absolute value, you'll use geometry because you can break it up into a bunch of triangles. All right, and we're going to practice that over the next coming days. All right, the next video is going to be pretty straightforward. I'm mostly going to go through and just write in answers so you can have them to check. I'll do a little more work for the limit summation though to show you. All right, so this one, we're going from 1 to 4. So we've shifted over just a little bit. I know that my final answer should be this blue triangle plus this green rectangle, okay? So I'm actually going to skip all the way to the bottom and tell you my exact area is 1/2 3 times 6 plus that rectangle 3 times 5. So this ends up being 9 plus 15, 24. All right, so building that concept, estimating with one right-hand rectangle, we should get 33. One left-handed rectangle, we should get 15. Three right-handed rectangles, we get 27. 3 left-handed, we get 21. Exact area using a limit summation. All right, so we have our limit summation. My function is 2x plus 3, and I'll fill in that x in just a second. The width of each of my partitions is 4 minus 1 over n. So in this case, 3 over n. So now when I fill in this middle part, I was starting at 1 plus b minus a over n I. Cleaning all of this up, this is going to be 2 plus 3, which is 5, plus 6 over n I, all times 3 over n. Multiplying that in, then we get the limit as n goes to infinity. Sigma I equals 1 to n. I'm so going to run out of room. 15 over n plus 18 over n squared I. Now we can use our formulas. This, where's my numbers down here? This is going to result in the green 15. This is going to result in the blue 9. We get an answer of 24. All right, hopefully this is coming together and that summary math joke helped you. Keep in mind you can come in during the MRC. We have a quiz the Tuesday, just Tuesday. If you're listening to this video in 2019. If we reuse this video, I can't speak to when your quiz is, but it's probably in a couple days. All right, thanks for watching. Have fun, do some practice, do some homework, try some stuff in the packet if you want to.